Hey folks, welcome back for another episode of Code Club. If you've been watching the channel for the past 6 or 7 months, you know that I've really been enjoying finding data visualizations out in the wild, bringing them in, and trying to make them using ggplot2 in R. I have been doing this so much that I now see things that aren't data visualizations and think they're data visualizations. So in early January, I sent out a newsletter to my mailing list, which if you're not subscribed to, what are you doing? Come on, down below in the description, you'll find a link where you can subscribe to the newsletter. And I showed them this visual, which is actually an album cover for the group OK Go, which I think is just a delightful band, and I really love their videos because they're out there, right? And so I saw this and thought, wow, that's like a genomics plot. That's a plot I would expect to see in a paper doing some type of genomic comparisons. We often think about having rings, and sometimes those rings have bar plots on them. And then I was like, oh wait, Pat, you're listening to Spotify. This is a album cover, right? And you can go into YouTube and you can find the making of the album cover, which basically involves using a turntable and then pouring paint over it at different speeds and for different lengths of time, and obviously different colors. And so in that newsletter, I talked about how I would go about making this. And one idea I had, I think, was to make an area plot. An area plot is an awful lot like a stacked bar chart, but where a stacked bar chart has different bars or stacks of bars at categorical positions across the x-axis, an area plot has a continuous x-axis. And I think we've talked about area plots actually in the last couple of episodes in making some of the other visualizations from the DuBois's collection of visualizations. And anyway, you could take that area chart and then you could express it in radial or polar coordinates. So typically we look at things in Cartesian, but we could wrap it in polar coordinates, and then we could get a circle like this. Well, as you know, I have also been going through the DuBois's collection of data visualizations from the 1900 Paris Exposition. There are all sorts of really intriguing visualizations like this one. This is plate 22 from his collection, describing the assessed value of all taxable property by Georgia Negroes, as it says. I am struck by this, right? Like a lot of the visualizations in the collections are just things we don't do, right? And I think, as I've said, the goal was to kind of get people's attention. These plates were 22 inches wide by 28 inches tall. So they were big, they're colorful, they're painted with watercolors. I mean, oh my, right? And so you would see something like this and be like, what is that? I need to go check that out. That is weird, right? So there's a variety of things I find intriguing about this visual. The first is that it's a set of concentric circles, right? And so when I look at these visuals that DuBois and his colleagues made, I kind of ask, like, why did they make it that way? Why didn't they make it normal, right? Why wasn't this a line plot, right? Which is probably what I would do, right? Make it a line plot. But here on the x-axis, valuation on the y-axis, we would see it growing, right? So why didn't they do that? Well, again, part of the goal was to draw people in and get people's attention. The other thing that these concentric circles say to me is that it's growing, right? That it's kind of like maybe rings on a tree growing out, or kind of a snowball. It's in the middle of February here, so we're thinking a lot about snow, a snowball getting bigger and bigger. But that the valuation is growing, and it's compounding or growing upon previous year's valuation, right? And so it makes sense then to have these spikes come from 1895 into 1875 because it's building, right? It's taking value from these previous years and it's expressing them forth in 1895 or 1900, right? So that's at least the story I can tell myself, right? So by using these plots that are different than what we're used to, our modern tooling isn't, set up to do this, right? So like there isn't a geom, well, whatever you're going to call this type of plot, right? Hadley Wickham and his crew hadn't come up with that yet, right? And so my question in these series of videos is, how can I make this plot that I think is really cool? How can I make it using ggplot2 and the other tools from the tidyverse? And so that's my challenge, is I'm trying to make an array of data visualizations from W.E.B. DuBois's collection of visuals from that 1900 Paris Exposition using 2 packages. Tidyverse, which, well, maybe that's a cheat. That's a bunch of packages, all part of the tidyverse universe. And then show text, which allows us to bring in fonts into R, right? Into the titles and the labels that we see here. And so that's what we're going to do. We're going to build this plot today. And I think it is funny that I talked about making that OK Go cover art. Never did because that just looked really hard. And we're going to try it out using this real data visualization from the 1900 Paris Exposition. I have a starter R script here that if you want to get this as well as all of the code that I generate over the course of today's episode, go down below in the description. You'll find a link to a blog post where you can get all of the code. One other thing to note is that I am using two fonts. I'm going to call this one B52 and this one Vasserly. At the first video of this series, I talk about how to get this, but also if you take these names, plug them into Google, you'll be able to get access to them. And these files are living in the same directory as my plate22.r script. I also then have a tibble where I'm defining the year and the valuation. Finally, I have a ggsave statement that gets us a width and height that are proportional to what we see in this original visualization. So let's go ahead and get going by loading our libraries, our show text stuff, and our tribble. And so now we can see that we have the year and the valuation. And so the strategy that I'm going to take is, again, to think of this as an area plot that we can then move from Cartesian coordinates to polar coordinates. And so let's do an experiment here, right? So I'll make a tibble, and x will be, let's say, 1 to 1,000. And then I'm going to have y be, let's say, 0.3, and then z be 0.7. And so that gets us a 1,000-row tibble with 3 columns, x, y, and z. I want y and z to be different areas of the area plot with x across the x-axis, right? And so to get that, we can then pipe this to pivot longer minus x. And that then gets us 3 columns, x, the name, and the value column, right? We can then pipe this to ggplot. So AES, x being x, y being value, and then fill being name, right? And then we can do plus geom area. And here we go. We now have our area plot. And a couple things we'll notice. Again, the x-axis is continuous. The y is also continuous. Also, the values in y and z add, right? So while y is 0.3, z is 0.7, they add up to 1, right? It's not like there's like 0.3 for y and then 0.7 for z. They add up, and so they stack. The other thing I notice is that it lays down the layers in alphabetical order, or opposite of alphabetical order, actually, right? So like z is at the bottom, starting at 0, and then y is on the top, right? And so we'll have to think about that with our years in terms of kind of the order of the years that we want. Now, let's go ahead and convert this to a circular plot using chord radial. There we go. You can hopefully see the makings of it. We have an extra missing wedge here, as well as a donut hole in the middle. And so we can get rid of that by removing the expand, right? So we've talked about expand in Cartesian coordinates. Well, this is what the expand looks like in polar coordinates. We'll say expand equals false. And so now we have our filled in circle, except for one little spoke right at about 1,000. And I think this is because of our x scale. So again, remember the x-axis is being used to set the angle, right? The theta, if you will, in terms of thinking about polar coordinates, whereas the y position is the radius. If you're making a pie chart using geom and chord radial, it's actually the opposite. The y is the theta, and the x, there is no x, right? So let's go ahead and add scale x continuous, and we'll do x lim. And again, I think it's the limits, so let's do 1 to 1,000. I want limits. Now the circle has been filled in. So hopefully it makes sense how we can go from like a rectangular area plot to basically bending it around in polar coordinates to make it look like this circularized area plot. So in the experiment, I had the full radius of the outer edge be 1, right? And I typically think of stacked bar charts in representing relative abundance. And so I think that's why I picked those two values to add up to 1, right? Here, our valuation data goes up to like 13 million, right? 13.4 million. And so I think what I'd like to do, just for having numbers that are nice to work with, is to put these in terms of a relative radius. And I want this 13.4 million, the outer edge, to be the radius of 1. And so typically when we think about like relative abundance, we might add all the values and use that in the denominator. But I think what we want is this 13.4 million to be in the denominator. So let's go ahead and pipe this to mutate, and then we'll say fraction equals valuation divided by max valuation. And so now we can see that the radius, or the outer edge, if you will, of that 1900 will be 1, and the 1875 will be 0.4 or so, right? And so we can use these kind of like we did with y and z in our experimental tibble, right? So let's go ahead and do that. Coming to this pipeline that we had, I'm going to subtly modify it to remove y and z. And I'm going to create 1875 as a column. And so normally I really don't like using numbers as column names, but I don't have a better name than 1875. And so if you need to use a number as a column name, again, I discourage it, although I'm using it here. But to do that, you need to put the numbers in backticks because you can't have variables that are numerics. So this 1875 then is going to be, what did I say, 0.401. I am hard coding the value here. Perhaps later we'll go back and we'll see if we can programmatically pull out these fractions. But I think we're going to have enough going on today that I'm not going to worry about that. And I'm going to be fine this time with hard coding the numbers. So then we'll also have 1880. And then that's going to be 0.429. And so if we go ahead and plot this, so we get our plot, a couple things that I notice. So first of all, the values are adding to each other rather than subtracting out from each other, right? So this should actually probably be like 0.28. The other thing that I notice is that 1880 is on the inside rather than the outside. So let's go ahead and fix both of those. So the 1880 is going to be 1880 minus 1875. And we're going to be doing this with the other years as well, right? So we're always going to be subtracting out the previous years from the current year, okay? And so we can do that with 1885, which will be what? 0.606 minus 1880 minus 1875. So that will get our 1885 data. Now the problem though is that 1880 was on the inside of 1875, and I actually want it to be the other way around. And so here in Pivot Longer, I'm using the default names and values columns, right? So we'll do names 2 equals year and values 2 equals fraction. And so then we're going to need to update this, right? So our fill is going to be the year and our y is going to be fraction. And so now we need to convert year into a factor. So we'll do mutate year equals factor on year. And then the levels, we're going to use a seek function to define all of the levels. And it's putting the smallest year on the outside rather than the inside. And so I think what that means is that we need to have 1900 on the outside and 1875 on the inside. And we're going to then decrease by 5, right? So that our levels will go from 1900, 1895, 1890, 1885, 1880, 1875, okay? And so let's go ahead then and pipe that into ggplot. So what we see is 1875 is in the middle with a green thin band for 1880 and then this reddish band for 1885. If we look at the original, again, we see that the 1880 is very thin, followed by 1885, which is thicker. Cool. So let's go ahead and add in the other years. So we'll do 1890 equals, so we have 1890 is 0.916 minus 1885 minus these years, and then 1895 equaling 0.962 minus 1890 minus these 3 years, and then 1900 is going to be 1 minus 1895 minus the rest of these years. All right, so that should be the 6 years. And so now what we see is that we have the bands that more or less look like the same relative thickness to what DuBois and his colleagues came up with. All right, but of course, this isn't the plot we want. We want these wedges to come into the plot, right? I think what I'll do is I'll start back with 1875, and I'm going to take each ring in turn, right? And so let's start with 1875 and see how we can modify this to get those wedges coming in. So if we look at it again, so I notice first of all that the wedges come into the 1875 data to about the same depth, right? So again, because we have 1,000, this is at 250, and so this is at 125, 375, right? And so we're on a pretty good increment. And so again, if we come back up here, we're going to have one at 125, 250, 375. So this is going to be between 500 and 750. So that's going to be 625. And then plus 250 more, so that will be 875, right? So those are going to be the x-axis positions where we have a wedge or a divot coming in. And so I'm going to set this up using a case when statement. So we'll do case when. And so case when x is some value, right? So let's do case when equals 125. Then we'll return 0.2. Otherwise, if x equals 250, then we'll say 0.2. X equals 375, 0.2. X equals 625, 0.2. X equals 875, 0.2. Otherwise, if it's true, if there's any other value, then we'll give 0.401. And then let's comment out that comma. And so now what we can see are our wedges coming into the inside of the circle. All right, but those are pretty thin. We need them to be thicker, right? One thought I have would be to say, if x is greater than 100 and x is less than, let's say 150, so it's centered at 125, then let's make it 0.2. We now have a flat bottom to the wedge, right? And also these sides are pretty straight, whereas over here, they kind of have some curvature. So instead of using a constant value of 0.2, I could use the formula for a line, but I'm going to have two formulas, so one between 100 and 125 and one between 125 and 150, and that's just too complicated. So instead, I think what we'll do is let's go ahead and use the formula for a parabola. And so I'm going to add 2.2, and we'll then do x minus 125, and then let's square that. And let's see what that looks like. And so that looks really weird. I'm not sure what that means. Let's turn off our radial coordinates for a minute. So from this vantage point, I can now see the 0.4 down here at the x-axis, right? But that these other values are going way above 0.4. So we want it to be at the same range as 0.4, right? And so if we had, say, 100 minus 125 and all that squared, that's going to be, I think, 625, right? So 625. What's 1 divided by 625? 0.0016. So let's try that. Although we're going to want it not 1, but 0.4 divided by 625. And so that's going to be 0.0064. So let's go ahead and use that as our constant, and we'll multiply that. Better, but for some reason that's not getting us all the way of what we want. So let's maybe take it down to 0.002, and that's what we want, right? Now we have the wedge coming out of it, and if we then show this in radial coordinates, we now see that wedge. Now let's go ahead, and I'm going to now save this to my PNG so that we're working in the same dimensions as the original. So good, that looks right. Let's go ahead and get rid of the legend. And so in geom area, we can then do show.legend equals false, and that's good. And of course, this is going to shrink down a bit because that's going to be this inner black circle. So let's go ahead and replicate that formula for the other positions, right? And so I'm going to go ahead and copy this down, and I'll put it below each of these other categories that I had. Then we will go ahead and update the values, right? So if x is greater than 225, and then x less than 275, and then this is going to be 250, and we can get rid of that, okay? And I've got one extra zero there, good. And so now we're going to do the same thing down here, where we're going to use 375, and it's going to be less than 400 and greater than 350. Get rid of that. And then here we have 625, and we'll put that there. And then this is going to be less than 650 and greater than 600. Get rid of that. And then 875, go there. And so then it's going to be less than 900 and greater than 850. Get rid of that. And I must have forgotten a comma somewhere. Oh, all the commas. So now we have all of our wedges in the right spots. Now what we want to do is go ahead and add in the other year's worth of data. And so now if we come to 1880, we're going to again do another case when. What are the wedges for 1880? So this one at 625 isn't going to get used. So we'll go ahead and remove that. And I'm thinking I can go ahead and grab all of this, right? And plop it in here. And we can then remove the 625. But the true value isn't going to be 0.401. It's going to be this 0.429 minus 1875. So that's pretty cool. That's pretty cool. We're adding 0.2, I realized. And so you can see like the vertex of this parabola is 0.2 away from the vertex of that parabola, right? We want it to be much closer. And then these fins, if you will, should hopefully get to be flush with the outer edge. So instead of 0.2, let's do 0.02. I'm going to use a variety of values. Let's do 0.01, 0.02, 0.03, and then let's do 0.05. Good. So I think I kind of like this 2 one. But why don't we go ahead and add our y limit so that we kind of have things at the right proportion. We can do scale y continuous, limits from z0 to 1. And yeah, so I do like this second one, which I think was 0.02. Let's go ahead and use that for all of the values. 2, 2, 2. But of course, we still have these spikes going out. And I wonder if we move in the borders a little bit, if those spikes won't go away, right? So if we did like 105 to 145, this will also give more room along the side of those spikes or wedges as they come through. So by bringing them in, we also got rid of those spikes. So let's go ahead and do that for all of these. We'll move them in by 5. All right. And then that 145 is right, and this will deduct the right side. So this will then be 395, and this will be 895. So this one at 250 is still spiking. Yep, I forgot to put that up to 230. Good. So those spikes are gone now. Cool. So hopefully we now have a strategy that we can go forward with for these other rings, because this is going to take a while. So now we'll go ahead and close out that parenthesis, and we'll then do 1895 equals, and I'm going to grab this whole case when, and instead of 0.429 minus 1875, we're going to do this 0.606 minus 1875. All right. And then what years are missing from the 1885 data? I think it's this lower right edge, right? So I think it's this 375 one, so we'll remove that. Let's go ahead and bring these in by 5 as well. 110, 235, 860, and then bring them in on the right to 140, 265, and 890. Oh, and I have one too many parentheses. So that filled in the red, and again, I can still see some of the color coming down in. It doesn't have to be really thick color, right? Like you can see that yellow coming in here, kind of like we can see that red coming in. I guess this red is the blue in the other one. All right, let's keep going. And now we want to do 1890. So I'll go ahead and bring that up. And then we'll do another case when, copying and pasting. There may be a more elegant way to do it, but hey, this is working pretty well. I'll bring in this 0.916 minus those years. But what years doesn't appear in the 1890? So the 250 goes all the way through. So we'll remove this one, and then we'll bring these in to be 115, 865, 135, and then 885. And I think we have an extra comma here. And I'm getting an error, object 1885 not found, and that's because I went straight to 95, 1885. Now again, this red corresponds to the yellow. Great. And now we want to do the next layer, and that's going to be the 125 missing, right? And so let's go ahead and copy this down, and now this will be 1895. Like I said, remove the 125, the first one there. And then we'll bring these in a smidge, and let's do 870 and 880. And then we're going to need this formula down here, the 0.962. And we'll plop that in here. Get rid of that extra comma. And I feel like that is such a long parabola going up and out that it perhaps doesn't need to come in as far as we currently have it coming in. Instead of 870, let's maybe make it 868. And then instead of 880, let's make it 882. Yeah, I think that looks pretty good. Again, our colors are radically different from what they had. And so now finally, we have the 1900. And that is not going to need a case when, right? That is going to be straight up 1900 equals 1 minus all of those other years. Very good. Now we have our outer ring in that red. Great. We do have some missing segments. I'm not totally sure what those are. I think my math is good. So I think my method to solve that will be to maybe put a red background, right? But let's go ahead and change our colors so they do a better job of matching what was in the original. So we'll do scale, fill, manual. We'll do breaks equals, we'll do a seek function. So we'll do 1875 to 1900 by 5s. And then our values is going to be a vector. So the inner circle is black. So it's going to be 6 zeros as the hex code. To match this tan color, I'm going to go ahead and use this hex code. And again, this is a DuBois style guide that I will link you to Anthony Starks' materials down below in the description. Plop that in. The next layer is the blue color, which we have here. And then we have the golden color. And so we'll grab that. Then we have like a gray color, which I don't see here. So I'm going to go ahead and use my own. I'll do gray, say 70 to get a lighter gray. And then we have the outer is the red or crimson, as he calls it here. Very good. I think those colors do a pretty good job of matching. Again, we still have these missing chunks. They happen to be right about where we were making those changes based on an X value. And so I think that probably has something to do with it. I wonder also if it might be that there's values that are sticking beyond the points and maybe going out beyond our limit of 1. What happens if I turn off my scale Y continuous? That fills them in. So I must be going beyond 1 ever so slightly. I'm not really sure what I'm doing to get that to happen. Maybe something we could check really quick here. So maybe after pivot longer, we could do a test here. And we could do group by X. And we could then do a summarize sum equals sum fraction. So it should sum across the years. And that gets us 1s, obviously. And then we can do an arrange minus sum. And that doesn't say anything. So I'm not really sure what's going on. It might be like a slight numerical precision thing. So I think what I'll do is I will use my scale Y continuous, but instead of 1, maybe I'll do like 1.001, and that keeps it filled in. So there must be a numerical precision issue going on here that is causing some values to be larger than 1, so that when I then use scale Y continuous with a limit of 1, it basically removes those values. Normally it gives a warning, but I'm not getting that warning, so I think that's cool. So this is the big hard part, which I know we're already kind of pretty far into this episode and we still have a lot to do. So let's go ahead and add in the years that we see down here, like at 6 o'clock or at X equals 500. And so let's see, what should we use? So again, we have the years here. Let's go ahead and call this data table fractions. Fractions we can bring into our overall pipeline. Actually, I've got some stuff in here that I need to clean up. So let's go ahead and remove this. Good. And then on top of geom area, we're going to do a geom text. And then our data is going to be fractions. And then our AES, the X is going to be 500. And then the Y is going to be the fraction, right? Because that is cumulative. Actually, it's going to be the negative fraction value, right? Because is it negative? No, I think it's actually positive. I'm getting myself turned around. Because it's at the bottom, I think it's negative, but I think it's actually positive. So we'll put in fraction. And then our label will be the year. And then we want to turn off inheriting the AES. So we'll do inherit.aes equals false. We have our years. We can't quite see them. And I noticed that in theirs, they have different font sizes and they have different colors. So let's go ahead and change the color. So it's going to go like white, black, white, black, black, black. We'll come back up to our geom text. And over here, we'll then do color equals, and I said that's going to be a vector of white, black, white, and then black, black, black. So we need to make these smaller, and we'll also need to position them. I'm going to make the font the B52 font. So let's go ahead and geom text. We'll do family equals B52, and size, let's start with 6, and so we'll do size dot unit equals PT. So that shrinks it down pretty well. And I think that size works pretty well for some of the years, but not all of the years. And so I think the 1875 and the 1885 are a good size, as well as the 1890. But ultimately, we're going to have to move things up a smidge. So let's go ahead and set the position so it's easier to see them in their real context. And so again, if we look at fractions, we get those fractions. And I'm going to add a column to my fractions tibble. And so we'll then say year pause. And for 1875, let's try like 0.38. I'm going to try some rough numbers and we'll go from there. And then 0.41, 0.58, kind of moving everything up just a smidge, 0.9, 0.94, and 0.98. Need a comma there. And then that year pause, I'm going to use in place of fraction. So we'll put year pause there. So I think that 1875 can go up. The 1880 is going to shrink a little bit, so it's probably in a good position. That 85 and 90, the 90 can go up. So let's move 1875 up and 1890 up. If I do them all at once, I'll forget. So let's put this up to say 0.36, and then let's make this 0.88. Great. The 1880 might need to come down a little bit, but it also needs to be a smaller font size. So let's go ahead into our geom text, and I have a size here, right? So I'm going to pull that to the next line, and I'm going to make a vector out of those sizes, right? And so the 1875 is good at 6. 1880 might need to go down to 4, and then let's fill in with the rest 6s. Okay, so I think that 1880 is going to be the right size. It does need to come down a bit. And I think the 1895 and the 1900 need to be smaller as well. Maybe not quite as small, so let's maybe make those 5 and 5. And then our 1880 needs to come down maybe 0.40. And I think I went the wrong direction with the 1880. But I think these 1895 and 1900s look good. And as I look at them, I'm kind of noticing that on the darker colors, they have the heavier B52 font. And in the others, they have the Vassarly font. Maybe I'll try to use the Vassarly font for everything, but let's go ahead and get this right. So I think this should be 0.42. Okay, so I think that 1880 is in a good, maybe it should be 0.415. Let's do that because it's going to annoy me. So let's go 0.14 and 5. Perfect. All right. Let's see what it looks like with the Vassarly font. So again, we can go up to geom text, and instead of B52, we can do Vassarly. So that looks okay. I'm wondering what it would look like if we mixed fonts. Can we do that? Oh, it's probably too much. So let's try. So we'll do B52, and then a Vassarly, and then a B52, and then a Vassarly. And it's going to be a few of those Vassarlys, right? It's going to be, I think the rest are Vassarlys. So total of 2 more. So let's see what this looks like. Let's see. It doesn't. I forgot a comma at the very end here, so wow, that worked. I did not expect that to work. That's pretty cool. I'm happy with that. Awesome. Honestly, I tried that and I didn't think it was going to work, but it sure did. Very cool. I probably would prefer to have the B52 for all of the years, but that's cool. Now let's think about the money, the valuation, both in the center of the plot as well as for each of the wedges. So we're going to do another geom text. And again, we're going to use data fractions, AES. So then the X, again, is the angle, right? And so that is going to be what? Well, we don't have that in here. So we're going to have to add the wedge position. So we'll do wedge, pause. So 1875 is the 0, so that's going to be at 0. And then 1880 is going to be that brown wedge that came in at 625 in the lower left corner there. And then 1885 is the blue, that is going to be at 375, right, at the lower right corner. And then 1890 is the yellow, and that came in at 250. And then 1895 came in at the upper left, so that's the 125. And then the red for the 1900 came in at the upper left. Did I say the 125 was upper left? That's upper right. 1900 is upper left. And so that is then going to be between 750 and 1,000. That should be 875. So then our fractions, the x is going to be the wedge, pause. The y then is going to be the position in the circle or in the area, right? Let's go ahead and just put that at 0.5 just to get things to look right. And then our label is going to be valuation. And then again, we're going to want to do inherit AES equals false. Let's go ahead and put that on the previous line. And then what else do we want? That's probably good for now. Let's go ahead and do family equals Vasserly. And it's complaining that something got removed. I see everything but the center. And that's because I put x of 0 when I only have an x of 1. So let's try that instead. That gets me my Vasserly font. I can't see the black. So that center needs to be white, as does the 1885, right? Let's go ahead and make a color aesthetic. And so we'll make a vector. So we'll go white, black, white, and then 3 blacks. All right, 1, 2, 3. So here is the value for the center, right? So there's a few things we need to do. So we need to get that 1875 right in the middle. We also need to format the values. So let's go ahead and do that first, because I feel like that's not going to hurt so much in my brain. So we'll do pretty fraction, and I will then do format fraction, and then I'll do big.mark equals comma. And so what that should do is to put commas after every thousandth place, right? And oh, that's pretty fraction. I want pretty valuation, not fraction. So I'll say pretty value, fraction here with valuation. I think I am getting tired, and so I'm doing silly things. There we go. And so now what you'll see is the pretty value, but there is a leading space. And we want to put a $sign at the front, right? And I don't want a space there. I think the argument is trim, so we'll do trim equals true. And so let's see if that trims that leading space. And do we have too many commas, too many parentheses? All right, there we go. And that did trim the front, cool. And then we can go ahead and do a paste 0 with a $sign and that format syntax, okay? And then close off the parentheses. And then if we look at fractions, we see we've got the $sign. Cool. So now in our label down here, we can do pretty value. And so now we have our dollars. Cool. I think before we place things vertically, we want to get the angle of the text right. Yeah. And in here we can do angle, and we'll do C, and I'll do 6 zeros to get us going. So the 1875, the first one is right. The second one is the 1880, and that needs to be at a 45-degree angle, I think. So let's go ahead and make that 45. Cool, that's right. And so also the fifth one also needs to be at a 45-degree angle, right? It's at the same angle as the 1881. So we'll go ahead and make that 45. And now we need to think about these two, right? The 1900 as well as the, that's 1885. And so I think that's negative 45. So let's go ahead and make negative 45 on the outer one. That's at the right angle. So this is the third one, 1885. That'll be a negative 45 as well. Let's go ahead and shrink the font down. Maybe before I shrink the font down, I'll go ahead and do that trick with different font families. That was pretty cool. And so where were we here? So again, we're going to do a C, and so we'll do B52, and then Vasserly, B52, and then we're going to want 3 Vasserly fonts. 1, 2, 3, comma. So I believe it was this one and the center that are the B52 font. Now let's go ahead and shrink them down. And so we'll do that after the family. Let's do size. So they seem to get bigger as they go out. The center one and the 1885 appear to be the same size as the year, which was 6. So let's do 6. And then the next one is quite a bit smaller. So let's do 4 and then 6. And then the next one is this yellow, which is bigger yet. And I think those other 3 are, let's say 8. That's a place to start, right? All right. And those are using the aesthetic size, not the point size. So our size.unit equals PT. So if I put these side by side, I think those fonts are pretty good size. Maybe the ones that I made a bigger size are still a little too big. And so those I made 8. Let's go ahead and make these 7s. Now we need to place these valuations. So I'm going to make another column in this fractions table. And then we'll call this label pause. And so this then is going to be 0 for 1875. Why don't I set the others to 0.5? And of course, we're going to fiddle with these a little bit to get them into the right spot. And then down in our geom text, I had 0.5. So here we want label pause. Now we need to adjust. So the next we need to adjust is the 1880. And that's a small font because that's a small area. So let's go ahead and move that 1880 in. Let's say 0.3. That's pretty good. It could probably come out a little bit. Let's make that 0.33. Perfect. Now let's do the 1885. Again, these are going to be center justified. And so I think it needs to be centered at like 0.4. So let's go ahead and bring that down. And then the next is the yellow, which is pretty close. So maybe it needs to go out to like 0.6. So we'll change that to 0.6. That's great. Then our 1895. So we'll change that to 0.8. Good. It could probably come in a little bit. It doesn't go all the way into the outer radius for 1895. Let's maybe make it 0.78. I think that's good. And then the final one, we know it should be, let's try 0.81. So I think we have all of the labels where we want them. The fonts all look good. Now we need to clean this up and get it a title. We haven't done anything in theme yet, so we'll do that now. So we'll do a theme. We'll do axis.text equals element blank. Axis.tix equals element blank. Axis.title equals element blank. Basically, we're turning everything off. So let's go ahead and add the title. So we'll come back up here and I'll do labs. Title equals assessed valuation of all taxable property owned by Georgia Negroes. They like to put a period at the end, I've noticed. And then we're going to want that to be centered. So we'll do plot.title equals element text. We'll do hjust equals 0.5. And we'll do family equals B52. Awesome. I think that font is a little bit too big though. So let's go ahead and say size equals 12. So I think that size looks good. And I think our left and right margins look pretty good actually. But there's a bit of a margin up here at the top that I just want to shrink. And I think we'll also demonstrate something that when we work in chord radial, sometimes it's a little bit finicky about the margins. So let's go ahead and try to change the margin on the top of the title. So we'll do margin t equals 0. And that actually brought the things closer together. So let's remove that. And then let's do plot.margin equals margin. I'll do t equals 0. And so that actually did pretty well, but that's clearly not a margin of 0, right? There's a lot of space up here. I wonder if we increase the bottom margin to push that up, if that won't help. So let's go ahead and do b equals 30. That moved it up, right? And now this goes up to like a margin of, I don't know, like 10, right? So now we can modify our top margin to be, say, 20. Somehow I think I just got that like perfectly dead on. Wonderful. I'm really happy with this. I think I've done a pretty good job of recreating DuBois's bullseye plot, or whatever you want to call this. I think it's pretty cool. I guess if I had my druthers, I'd use a consistent font for all of the labels within the plot. I'd probably go to B52 for everything, just so nothing kind of gets lost in these darker colors like this red, right? Like it's kind of hard to see that 13 million or this brownish, grayish gets washed out as well. But anyway, I think we've done a good job. I've learned something. I learned you can change your font family for different values, and that's pretty cool. Let me know what you think about this overall design and kind of my interpretation of why he perhaps went with this design of kind of showing expanding concentric circles across time. I think it's pretty cool. I don't have an immediate application for how I would use this for my own research, but I think it's pretty cool. Maybe you could quibble with different things about like kind of the thicknesses of these wedges, perhaps not being as thick as his. I'm looking at this 1900 and thinking that mine should perhaps be a little bit wider, but who cares? I'm happy with this. I think we've done a pretty good job of recreating things that, frankly, I didn't think we'd be able to do. Let me know, again, what you think about this series of episodes, going through these DuBois data visualizations and trying to recreate them using tools from the tidyverse. I hope that you've already hit the thumbs up button on this video so that the algorithm tells you that the next video has been posted. And I also hope you tell your friends that you give the video a thumb up so that they're inspired to watch these along with you. Anyway, keep practicing, and we'll see you next time for another episode of Code Club.